Hi, my name is Fatih. I am a machine learning engineer here at webAI.
And I'm Sam, and I'm also a machine learning engineer here at webAI. So initially, when we started the project, we thought the scope would be pretty much just classifying images of the cargo hold and making sure that the fire suppression line within those cargo holds are visible.
It sounded like a simple image-based check, right? Ground crew takes a photo and our system verifies if the fire suppression line is visible or not.
It ended up turning out to be a bit more complex than we anticipated. Going into the data side, a project like this, a lot of the times a real world environment, all that data is collected, can be super messy, right? We were initially expecting, really clean images of these cargo bays, but we soon realized we were getting images that were really messy. They contained a lot of noise, like somebody's finger was over the lens when they were taking the picture. And then even the quality of issues, we saw a lot of issues with.
Exactly. And the data set was super unbalanced. So we weren't seeing too many examples of good images, for instance, where the fire suppression line is clearly visible. A lot of them were, totally irrelevant outside of our scope, project scope. So it was a really messy and unbalanced data.
Yeah, so there was about 60,000 images. We realized, we're not just solving, is there a fire suppression line there?
Yeah.
We also then had to solve, is this the right kind of photo to validate? So we received a lot of great data points to train a model capable of solving this type of solution. But as Fatih mentioned earlier, there was just a lot of noise. So we then had to go in and making a automated pre-processing pipeline, which kind of helped us filter out those images.
But we still had to, go over the images manually because we wanted to make sure that the labels were correct and the models had clean images, from the training set. So yeah, after using this automated pipeline, we had to do some manual work as well. So yeah, after we started reviewing the data set, we saw how messy it was. So that's why we had to come up with a practical solution where we can, detect this fire suppression line with a high accuracy. One thing that we tried was using a single model to do everything, but due to the noise in the data set, as we mentioned, so we had so many blurry images, we had so many images with poor lighting or misaligned ones, or again, totally irrelevant images. That single model approach was failing badly, so that's why we came up with this two-stage architecture, where we first check if the photo is taken from the cargo bay area, and then after verifying that it's from the valid location, then we go check the quality of the image, where we basically try to filter out those poorly lit or misaligned images, and in order to get the good ones, filter out the good ones out of those.
Yeah, it was extremely important that the customer was able to identify not only the fire suppression line, but also classifying those different types of images that we saw in the data set. So even though we experienced a lot of different variety in terms of what kind of images we got in the data set, they were still useful in our two-stage architecture and being able to accurately validate an image.
We were the first ones. We were the first company that designed this type of system, because before this it was totally in hands of the ground crews. So most of these companies, they didn't have any control in this process, so they were all in hands of the ground crews. If they say the fire suppression line compliance is valid in that flight, then it was it. So we designed the system so the airplane companies can control, this safety issue by themselves.
Yeah, it completely empowers the actual grounds crew to get instant feedback on the types of images they're taking. Because previously there would be steps that needed to have happened for them to accurately validate an image, which can be time consuming. And so we've completely reduced that by instant real-time feedback on those types of images.
So we wanted to use this lightweight model because we want the system be ready for edge devices. So everything right now runs on cloud, but it's also ready for edge usage. We can run this on a mobile device with same speed and accuracy, scores.
Yeah, and splitting the problem into two focused models help us achieve a higher accuracy while also achieving sub-second performance.